Today we're going to be learning about transforming points and figures. We're going to start off by quickly reviewing the transformations that you should already know. First, I want to remind you that when you transform a point, in this case as point A, then the image of the point after the transformation is going to be called a prime, and this is how we write it. The first type of transformation we're going to look at is translations. When a point is translated, then the point is moved or shifted. Translation transformations produce congruent figures, changing the position of a figure but not its shape or size. Translations can be horizontal. Translations can also be vertical, or they can be a combination of both. The next type of transformation we're going to look at is reflections. With reflections, points are flipped over a line of reflection, resulting in a mirror image. Reflection transformations also produce congruent figures, changing the position of a figure but not its shape or size. There are a number of different lines of reflection that are possible. The ones that you should know already are first the x-axis. So a possible line of reflection is the x-axis, and when a figure is reflected of the x-axis, it'll look something like this. Another possible line of reflection is the y-axis, and if a figure is reflected of the y-axis, it will look something like this. Then you should also know about rotations. With rotations, points are turned around a point of rotation, which is usually the origin. Rotation transformations also produce congruent figures, changing the position of a figure and not its shape or size. Possible rotations include 90 degrees clockwise. So if you rotate this figure over here 90 degrees clockwise, it will look something like that. It's being rotated about the origin. We also have 90 degrees anti-clockwise, which will look like this, or 180 degrees about the origin, like that. Then we have enlargements and reductions. With enlargements and reductions, points are enlarged or reduced by a factor. Enlargement and reduction transformations produce similar figures, changing the position and size of a figure, not its shape. So this is different to the other transformations we've done. With translations, reflections, and rotations, they all produced congruent shapes, and the size of the figure did not change. But for enlargement and reduction transformations, they produce similar figures, and the position and the size of the figure is going to change. But the shape is still going to stay the same. The center of enlargement is usually the origin. So over here I've got an example with figure A, which is going to be enlarged by a factor of 2, with 0 as the center of the enlargement. So the distance from the origin to each point in the figure has now doubled because it was enlarged by a factor of 2. So this distance was one diagonal block. Now it is 2 diagonal blocks in the same direction. Here, this is one diagonal block. Now it's 2 diagonal blocks in the same direction. This one over here was going up 2 and across 1. Now it's going up 4 and across 2 in the same direction. So the distance from the origin is what is being enlarged or reduced for each point in the figure by that factor. In this case, the factor was 2. Then for enlargements and reductions, you also need to remember that when a figure is enlarged by a factor and reduced by a factor, it works the same, then the perimeter is enlarged by the same factor, and the area is enlarged by the factor squared. Okay, now we're going to introduce reflections with 2 new lines of reflection. We're reflecting in the line y equals x and the line y equals negative x. First, the line y equals x is this line over here. Every point on this line has identical x and y values to each other. So if you look at this point over here, it has the coordinates 1, 1. X and y are the same. Here, the coordinates are 2, 2. Again, x and y are the same. Over here, the coordinates are negative 4, negative 4. Again, x and y are the same. So everywhere along the line y equals x, y is equal to x. The x and y values are equal to each other. They are the same as each other. If I reflect an image in the line y equals x, it will look something like this. Okay, then we also have the line y equals negative x, which looks like this over here. So everywhere along the line y equals negative x, the coordinates, the x and y values will have the same absolute value, but they'll have different signs. So one will be positive and one will be negative. So you'll have positive and negative 1, positive and negative 2, positive and negative 3, and so on. So over here, the x values are going to be positive and the y values will be negative, but they are both 2. So it's 2 and negative 2. But here, the x values are going to be negative and the y values are going to be positive. So here I've got negative 3 and 3. If I reflect an image in the line y equals negative x, it will look something like this. Remember that when you are reflecting a point, the reflected point must be located on the opposite side of the line of reflection at an equal distance. Okay, so let's have a look at an example. So over here we're going to write down the coordinates of point B prime, which is the image of B, which has the coordinates 2, 6, reflected in the line y equals x. Okay, so first let's have a look at where this point is. Okay, so the point is over here, where x is 2 and y is 6. If I draw in my line of reflection, it's this line over here because it's y equals positive x. So it's going to be that line over there. Now, if I want to reflect the point B in that line of reflection, then I need to see how far is it at its shortest distance. So I'm not going this way, I'm not going this way. I'm going to be going and finding the perpendicular distance to the line y equals x. So this is 2 diagonal blocks away from the line y equals x. So now I'm going to go the same distance on the other side to find out where the reflected point is going to be, and it's going to be over here. So this is going to be my image, which is B prime. So that is the point B prime over there. So then the coordinates of that point are going to be 6, 2. So if I have point B, which is 2, 6, then when I reflect it across the line y equals x, then the coordinates of point B prime are going to be 6, 2. Right, let's have a look at another example where we're working with the line y equals negative x. So this time we have the same point. It's still the point B, which is 2, 6. But now my line of reflection is going to be this line over here, the line y equals negative x. So remember, I'm going to find the shortest distance from the point to the line. So that's going to be this distance over here. That's 1, 2, 3, 4 diagonal blocks. So now I'm going to go the same distance on the other side over here. That's 1, 2, 3, 4, leaving me with this point over here. So if I go and put in my point, that is the point B prime, which is the image of B when it's been reflected in the line y equals negative x. And the coordinates of this point are negative 6, negative 2. Okay, so if I've got the point B, which is 2, 6, when I reflect it in the line y equals negative x, I'm going to end up with the point B prime, which is negative 6, negative 2. Now we're going to go on to an activity where you're going to do a few of these yourself. So you're going to write down the coordinates of the image of each point after the given transformations. The first point you're doing is the point A with the coordinates negative 4, 3, and you need to reflect the point A about the line y equals x. I'm going to give you 30 seconds to find the coordinates of the image of point A. Okay, so let's go through that and see what you should have got. So first of all, the point A is this point over here. It's negative 4, 3. And if you put in your line that you're going to be reflecting in, the line y equals x is this line over here. Okay, so we need to find out what the shortest distance is from A to that line. So that distance is this over here. So it's 1, 2, 3.5 diagonal blocks. So now we're going to go the same distance the other way. So I've got a half, 1.5, 2.5, 3.5. So this is how far I need to go over here, and then the A prime is going to be this point over here. And the coordinates of that point are 3, -4. So that you should have got for question A. Right, let's go on to question B. In question B, you have point B with the coordinates -2, -3, and this time you're reflecting across the line y equals -x. I'll give you 30 seconds for this one as well. Okay, so let's go through that. So first we're going to plot the point B, which is this one over here, -2, -3. Then if I put in the line y equals -x, it's going to look like this. This is the line that we're going to be reflecting across, and it has the equation y equals -x. Right, now I need to work out where B prime is going to be. So let's find out what the distance is from B to the line y equals -x. So that's 1, 2.5 diagonal blocks. So we're going to go over here, half, 1.5, 2.5. So this is going to be over here where I'm going to have my B prime. So that's the point B prime over there. And it has the coordinates 3, 2. Right, let's go on to question C. In this one, you've got the point C, which is 0, 0, and it is reflected in the line y equals x. I'll give you 30 seconds for this one as well. Okay, so let's go through that. So first of all, we're going to go and plot the point C, which is the origin. It has the coordinates 0, 0. Then when we draw in the line y equals x, it's going to look like that. Now, the distance from the point C to the line y equals x is 0 because it's on the line. So when I reflect it, I don't need to go any distance away from the line y equals x on the other side because it's on the line. So the point C prime is the same as the point C over there. So it also has the coordinates 0, 0. So that you should have got for question C. And then question D, you've got the point D, which is 2, -1, and it is being reflected over the line y equals -x. I'm going to give you 30 seconds for this one as well. Okay, so let's go through that and see what you should have got. So first of all, the point D is this point over here. It has the coordinates 2, -1. Then if we draw in the line y equals -x, it's going to look like that. The distance from the point D to that line is half a diagonal block. So we're going to go half a diagonal block in the opposite direction. And that's going to give us the point D prime, which has the coordinates 1, -2. Okay, now let's go on to the next activity. The first thing you're going to do in this activity is draw triangle PQR with the vertices P, -2, 1, Q, -1, 5, and R, 6, 0. I'm going to give you 30 seconds to draw this triangle. Okay, so first of all, the point P has the coordinates negative 2, 1, so that's going to be this point over here. Q is the point negative 1, 5, so that's over here. And R is the point 6, 0, so that's over here. Then when you join it up, you get a triangle that looks like that. Okay, the next thing you're going to do is you need to draw triangle P prime, Q prime, R prime, which is the image of triangle PQR after it is reflected in the line y equals x. I'm going to give you 1 minute to do this question. Okay, so for this question, first I'm going to draw in the line y equals x so that I can see the line of reflection. Then I want to see how far each point is from the line of reflection and draw its image on the other side. So for point P, it's 1.5 diagonal blocks. So 1.5 diagonal blocks in the other direction is going to end up over here. So that's going to be the point P prime. The point Q is 1, 2, 3 diagonal blocks. So I'm going to go 1, 2, 3 in this direction. That gives me the point Q prime over there. And then the point R is on this side of the line y equals x. So I'm going to be going the other way. So I'm going to go 1, 2, 3. So again, it's 1, 2, 3. So I'm going to end up over there. So this is what you should have got for your triangle P prime, Q prime, R prime, which is the image of triangle PQR after it has been reflected in the line y equals x. Now the next question is to just write down the coordinates of P prime, Q prime, and R prime. I'm going to give you 30 seconds to do that. Okay, so you should have found that the point P prime has the coordinates 1, negative 2, Q prime has the coordinates 5, negative 1, and R prime has the coordinates 0, 6. Okay, now let's go on to the last activity for today. In this activity, you're going to plot the images of points A to Q after the specified transformations, working on the grid provided. So if you've got the worksheet that goes with this lesson, then you can just use the one that's provided. Otherwise, you can take a quick screenshot and print out the grid that I've got on the screen here. After you've plotted each image, you're going to join the points in alphabetical order. So it's kind of going to be like dot to dot, except that you have to first find out where the points are before you can join them up. Okay, so let's go and look at the points and their transformations. Okay, so here you've got all the points and their transformations. You need to work out what the coordinates are going to be of the images of these points after the specified transformations that you can then fill in. And then once you have found those coordinates, you need to go and plot them on the Cartesian plane and join them up in alphabetical order. Okay, so over here you've got the point A, which is negative 3, 7, and it is translated 2 units to the left. So you have to find out what the coordinates of that point would be after it's translated 2 units to the left, which is A prime. And then you're going to go and plot A prime on the Cartesian plane. Please note you're not plotting A, you're only plotting A prime. And then for B, you're only going to plot B prime as well, and so on. Okay, I want you now to pause the video and do this activity, and then you can come back and I'll go through it with you. Now hopefully you've finished the activity, so let's go through it and see what you should have ended up with. So the first point we're going to look at is the point A, which is the coordinates -3, 7. And we're told that it is translated 2 units to the left. So -3, 7 is going to be over here. And if we go 2 units to the left, we're going to end up with this over here, -5, 7. So the point A prime has the coordinates -5, 7, and it's going to be over there. Then the next one is the point B, which is the coordinates 3, 7, and it is reflected in the y-axis. So 3, 7 reflected in the y-axis will give you this point over here. So that's going to be -3, 7. So B prime is -3, 7. If I join those up, I get that over there. Right, now the next one is the point C, -2, 12. Now I can't even plot that because the grid isn't big enough. But we're told that it is reduced by a factor of 1/2. Now when you reduce by a factor of 1/2, it means you're going to take the coordinates and you're going to halve each of them. So half of -2 is -1, and half of 12 is 6. So you're going to have the point C prime, -1, 6. So that's this point over here, and I join it up. Then D is the point -6, 4. And it is translated 6 units to the right. So -6, 4 is over here. If I go 6 units to the right, I'm going to end up over here. So D prime has the coordinates 0, 4, and that's that point over there. Then E has the coordinates 6, -1. So that's this point over here. And it is rotated 90 degrees anti-clockwise. So we're going this way around. So the coordinates of E prime are going to be 1, 6, and I plot it like that and join it up. Then the point F is 7, 3, so that's going to be over there. And we're told that it is reflected in the line y equals x. So when you reflect that, you should have ended up with 3, 7, which is over here. So the point F prime has the coordinates 3, 7. I plot it like that and join it up. Okay, then the point G has the coordinates -5, -7. So that's going to be over here, -5, -7. And it is rotated 180 degrees about the origin. So I'm going to end up with this point over here, 5, 7. So the coordinates of G prime are going to be 5, 7. And I plot it and I join it up. Then I've got the point H, which is 10, 3. So that's going to be over here. I can't even actually get to it. But if I go 3 units left, as they say, there's 1, 2, 3, and then 3 units up, 1, 2, 3, I'm going to end up with this point over here, which is 7, 6. So H prime is 7, 6, and if I plot it, it goes over there, and then I join it up. Then I've got I, which is 2, 1. So 2, 1 is over here. It is being enlarged by a factor of 4. So this distance has to be multiplied by 4. So I'm going to go 1, 2, 3, 4 to over here, which is the same as multiplying each of them by 4. So that gives me the point 8, 4. So the coordinates of I prime are going to be 8, 4, which I plot over here and I join it up. Then I've got J, which is 0, 8. So that's going to be over here, 0, 8. And it is rotated 90 degrees clockwise about the origin. So it's going to go this way. So the coordinates are going to be 8, 0 for J prime. If I plot it, I get that over there and then I join it up. Then I've got K, which is 6, 4. So 6, 4 is over here. It is being reflected in the x-axis. So I'm going to go down to there, and that is K prime. And I plot it, and it has the coordinates 6, -4, and I plot it and I join it up. And then I have L, which is -2, -4, so that's this point over here. It is going to be translated 2 units to the right. That goes 1, 2, and then 4 units down, 1, 2, 3, 4. So I end up over here, and this point L prime is going to have the coordinates 0, -8, and I plot it and join it up. Then I've got the point M, which is 4, 6. So over here I've got 4, 6, like that. And it needs to be reflected in the line y equals -x. So if I go from 4, 6, like here, I go 1, 2, 3, 4, 5 diagonal blocks. 1, 2, 3, 4, 5 diagonal blocks. That gives me the point -6, -4. So the coordinates of M prime are going to be -6, -4. And I plot it like that and join it up. Then I've got the point n, which is 4 zeros, or negative 4, 0. So this is n over here, and it is going to be enlarged by a factor of 2 about the origin. So remember, when you're enlarging, the distance from the origin to that point has to be doubled because it's a factor of 2 in the same direction. So it's going to go all the way to the negative 8. So it's going to be negative 8, 0 for n prime. And I plot it like that and join it up. Then O is negative 8, negative 3. So over here I've got negative 8, negative 3. And it needs to be translated 7 units up. So I've got 1, 2, 3, 4, 5, 6, 7. That gives me this point, which is the coordinates negative 8, 4. So that's the point O prime, negative 8, 4. And I plot it and join it up. And then I'm almost done. Now I have the point P, 6, negative 7. So that's this point over here. I need to reflect it in the line y equals x. So I'm going 1, 2, 3, 4, 5, 6 and a half diagonal blocks. Half, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5 diagonal blocks. So the point that I'm going to get over here is going to be negative 7, 6 for P prime. Negative 7, 6. So I go and plot that, and I get that, and then I join it up. And then the last one, point Q, is the point 5, negative 7. So that is going to be over here, 5, negative 7. And it is rotated 180 degrees about the origin. So it's going to, and it doesn't matter what direction it goes. So 180 degrees about the origin is going to get me to this point over here, which is the same as my starting point, which was A prime. And that has the coordinates negative 5, 7. And when I join it up, I end up with that. So that's what you should have got for that activity. And that is how we transform points and figures on the Cartesian plane. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.